All right, so 358.71, starting a new chapter. If you look at our poster over there, we have 8 sections in this chapter. Okay, it is a long chapter. Some of them we're going to split up into 2 days even. There's a lot of good information, a lot of important information in here. So we are going to be on chapter 7 for a while. Okay, our quiz is not until next Thursday. Okay, that's the day before midwinter break. Okay, so it's that Thursday. We have Friday, Monday off after that. Yeah. All right, so 7.1 is kind of an intro. There's a lot of stuff that we got to talk about, that we got to get through here, that you're going to want to take notes on, because it's new stuff that we haven't necessarily talked about before. We're starting with this idea of a monomial. Okay, I want you to copy that down. What does the prefix mono mean? Means 1. Okay, so a monomial is like 1 term. Okay, and we'll talk about what that means here. Let's copy that down and then we'll talk about it. So a lot of different things that a monomial could be here. So it could just be a number, right? Just a number, that's a monomial. That's fine. Could just be a variable. Also okay, that's considered a monomial. But then we get into, it could be the product of a number and a variable. So you could have a number and a variable together. Right, that is a monomial. You could have exponents on it, that's okay. We could have more than one variable together, and that's okay. Things that we cannot have, okay? We cannot have any addition or subtraction in there. Okay, no addition or subtraction. It's got to be all just multiplied together for it to be considered a monomial. Because this is really just 1 term. And a term is kind of defined as something that you would add to something else. So there's no addition or subtraction within it. Okay, it's all just multiplication. The other thing to point out, when we see the word whole number, we tend to think of that just meaning no decimals, no fractions, which is true, but in mathematical speaking, whole number means it has to be positive as well. Okay, so a whole number has to be positive. So no negative exponents, no fraction exponents, and nothing else weird going on. We're not going to have a square root over the variable. We're not going to have the variable in the denominator. Right, the variable isn't going to be the exponent. We're not going to see any of those things. Okay, it's going to be pretty straightforward. Just a number, number variable, exponent combinations. Okay, so these are considered monomials. Any questions right now on what a monomial is? Yeah.
You give an example of
what it wouldn't be? Sure, something like that. Not a monomial. That's not a monomial, right? So anytime you have addition or subtraction in there, that is not a monomial. Okay. Yeah, if you have a negative exponent, right, can't do that. You can't even if we change that over into 1 over, we still can't do that. You can't have a variable in the denominator. Right, so all of these are not monomials. Okay, anything else? Any other questions on monomial? Okay. The next thing that we got to talk about in terms of a monomial is this idea of the degree. The degree of the monomial. And to find the degree of the monomial, we are going to add all the exponents of the variables. Okay, so I'm going to say it's the sum, because I'm going to use the fancy word, the sum of the exponents of the variable. So it's the sum of the exponents of the variables, and only the variables. Sum, of course, means addition. We're adding them together. So we're going to look at the degrees here. Let's start with the 5y to the third. What's the degree going to be? 3. Okay, nice and easy. What about 3y? It's going to be 1. Remember, anytime you have a variable that doesn't have an exponent, that exponent is a 1. It can't be a 0 because anything with a 0 power is 1, right? And that would just cancel out, and we would get rid of that variable. So if it doesn't have an exponent, the exponent is 1. So that has a degree of 1. What about just the x? 1. What about just the 4? 0. It's the sum of the exponents of the variables. Is there a variable? So there's no exponent. So it's 0. So if you just have a number, if there's no variable, then your degree is 0. Okay, and how about the bottom one? 5. Add them together, we get 5. Okay, so only the exponents of the variables. Okay. Tell the person next to you what the degree is going to be and why. Okay, Aiden, what do you think? Why?
Because x to the second, x squared, and then y, the exponent of 1, b to the exponent of 1, and the 3 cubed doesn't count.
Yeah, because we're only counting the ones with the variables, right? So we're adding those together. This would have a degree of 4 for that one. Okay, so don't worry about the exponents on the numbers, just the variables. Okay, good. Questions on that? All right, let's move on. So we talked about monomials. Now we got to talk about polynomials. What does the prefix poly mean? Multiple, right? So we're going to write down some stuff about polynomials here. And it can be a little confusing, at least at the start of the definition, because a monomial is also considered a polynomial. It's a little weird like that. But a polynomial, what this allows us now is to get those addition or subtraction in. Okay, so a polynomial could be just that one term, but it could also be more than one term. I want you to take a couple minutes. I want you to copy this down, okay, so that we have it in our notes. We can study from it, and then we'll talk about it. All right, as you're finishing that up. So a polynomial is a monomial or a sum of monomials. Sum means addition, but it could also be subtraction. So we could have minus signs in between, completely okay. All right, so it's addition or subtraction there. Each monomial is considered a term, like I've been saying, right? This is more than one term. So the terms are the ones separated by the addition subtraction. And if we have two terms, it's a binomial, like bicycle, bi. Right? If we have three, trinomial, tricycle, three, right? Trinomial, triangle, right? Tri means three. So they might ask you to classify the polynomial by number of terms. That's what this is. It's a binomial, it's a trinomial, it's a monomial based on number of terms. Anything more than three, we just call it a polynomial. Okay? We don't have a special word for 4 or 5. Yeah.
Can you do subtraction or just addition?
You can do subtraction as well. Yep, they just didn't show it here, but we'll see it as we move forward. Yep. All right, so we're going to deal with polynomials today. We got to find the degree of the polynomial, just like we found the degree of the monomial. To find the degree of the polynomial, this is different, and this is probably the number one thing that people mess up from this section. Because you're going to be tempted to simply add up all the exponents, and that's not it. Okay, that's a monomial. When you see addition or subtraction, okay, you cannot add the exponents over those. You got to find each term individually. So we're finding the degree of each term individually. This has a degree of 2. This has a degree of 1. This has a degree of 0. Once you find the degree of each term, the degree of the whole thing is just the biggest one. It's just the biggest one. Okay? It's the biggest degree of a term that you have. So for the trinomial, our degree would be 2, because that's the biggest one. Now, most of the ones that you're going to see are going to be just one variable, one exponent. So really, you're just looking for what's the biggest exponent. Okay? We just can't do that if we have more than one variable together. Right? In this trinomial, now I've got more than one variable together. So when I go to find the degree, I have to add these two up because that's in one term. Right? So this degree is 5, and then 4, and then 1. So the degree of the whole thing then would be 5, because it's the biggest term. Not necessarily the biggest exponent, but the biggest term. Okay? Dave?
What if all the degrees are like the same?
If they're all the same, then that's your degree. Yeah. Okay, so that's how we find the degree of that polynomial. Okay, find each term individually, the degree of each term, take the biggest one. Now you'll notice for these that we have written here, the binomial, the trinomial, they are written in order so that the biggest degree comes first down to the smallest degree. Right? This is 2, 1, 0. This is 1, then 0. This is what we call standard form. Okay, standard form. Standard form, you're going from biggest exponent to smallest exponent. Okay, biggest exponent to smallest exponent. Or biggest degree to smallest degree. But most of the time, again, you're just going to see one variable, one exponent. So here's an example of standard form. Bless you. Okay, standard form, biggest exponent down to smallest. The reason why we do this is so that we can all agree on the order which these terms go. Because you could have this this polynomial, that polynomial, and this polynomial represent the same amount. They represent the same exact thing, right? There's a lot of different orders that we could rewrite this in, because you remember you can add in any order. There's a lot of different orders that we can go. In order for everything to be standardized, right? That's where standard form comes from. We need to use the same form. We need to agree on it. And Big Ideas is not going to accept your answers unless you put it in the standard form. Okay? You have to put your answers into standard form. Biggest exponent first, down to your smallest. Couple other things to point out. The one without the variable is called the constant. Okay, without the variable is called the constant. Remember, variables, the word variable means to change. Right? So variables change things. So if it doesn't have a variable, it's going to be constant, which means it stays the same. So without the variable is the constant. So that's important to know because we will refer back to the constant. You got to know that's the one without the variable. The word coefficient. Sorry, yeah.
Does the addition and subtraction signs have to stay in the same spot?
So the addition and subtraction signs belong to the term after. Okay, so that minus belongs to the 5x. So wherever the 5x goes, that negative has to go too. Okay, that's a good question. The word coefficient, if you recall, the coefficient is the number in front of a variable. Okay, coefficient is the number in front of a variable. So each term here has a coefficient, has a number in front of the variable. Right? Here is 2. What's the coefficient in front of x squared?
1.
It's a 1. If there's nothing there, it's a 1. We got -5, we got 12. So there are coefficients in front of every single variable. What's considered the leading coefficient? The leading coefficient is when you're in standard form, the very first one. Okay, so leading coefficient is in standard form, the very first number. The very first coefficient when it's in standard form. But it has to be in standard form first. It's not just whatever term is listed in your problem. It's once you put it in standard form, what's the first number? Okay, any questions right now on polynomials, degrees, leading coefficients, standard form? A lot of small things that I'm throwing at you. Okay. So I would like you to take this one, 15x minus x to the third plus 3. I want you to write it in standard form. And I want you to think about what the leading coefficient is going to be. Talk to somebody about it. See if they have the same thing. All right, raise your hand. What is our standard form going to look like here? What's our standard form going to be? AJ?
Negative x to the third power plus 15x plus 3.
Perfect. Because remember that negative belongs to that x to the third. So if that goes out front, the negative goes out front with it. Okay, that's one of the reasons why I wanted you to feel comfortable not having to write plus and negative for subtraction. And so that we can look at this and we don't have to change it to plus a negative. We can just say, all right, that's a negative. Let's move it up front. Okay. All right, good. We're here. Raise your hand. Somebody else. What is the leading coefficient going to be here? Andrew?
15x.
Nope. Not on this one. Ava? -1. Because it's once we put it in the standard form, it's the number out front. And in this case, there's no number there. It's got to be a 1, but there is a negative. So it's a -1 for that. Okay, very important. -1. You got to put it in standard form first. Okay. Good. Questions on that? Okay, we're not done yet. Told you a lot of stuff today. Next thing that we got to look at is we need to add polynomials together. We're going to add polynomials together. I want you to write this one down. So we've got 2 trinomials here. Right? Remember, trinomials have 3 terms each. And we're adding these 2 trinomials together. Now, addition is pretty easy. Because we are adding, what we can do is we can ignore the parentheses and just combine like terms. We're just going to ignore the parentheses. We're going to combine like terms. Remember, like terms, though, have to have the same variable and the same exponent. Same variable and the same exponent. So you cannot combine something x to the third to something x squared. Okay, so I want you to go ahead and do that. I want you to combine your like terms. Same variable, same exponent. Make sure your answer is in standard form.
Nice.
So you're not going to change the exponent. So you combine x to the third, x to the third. You're just adding the numbers to one, and it's going to stay x to the third. Check somebody, see if they have the same thing.
Oh, so that would be 3x, I think.
All right, here we go. Here we go. Finn, what do you have?
3x to the third minus 3x to the second plus x.
So when we do this, all right, if I'm sitting down to do this problem, I'm going to mark it up. I'm going to say, all right, those I am combining, and then these I am combining, right? So anything with the same variable, the same exponent, those are what I'm combining. So 2x to the third plus 1x to the third gives me 3x to the third. I have negative 5x squared. Remember that sign belongs to the term after it. So when I circle it or I box it, I take that sign with it. I have negative 5x squared plus 2x squared. Give me negative 3x squared. And I got a plus x, and I got a minus 1. I always mark it up. I'm circling, I'm squaring, I'm making a triangle around it, I'm underlining. That way I know what I combined. I know I didn't miss anything. Because if you start adding a bunch of these together, you don't want to miss one term, right? So it makes sense just to circle it or make some sort of mark so that you know you got all of them. Okay? I'd hate for you to miss a problem because you missed this plus x that's in the middle. Okay? All right, any questions about adding? Ignore the parentheses, combine like terms. Okay, last thing that we have then is subtracting. Okay, so we've got subtracting. Let's copy this one down. I'll erase the rest of the stuff for you. Copy this one down. We'll talk about it, and then we'll be done. All right, so we know we can't just do the same thing we just did because it's not addition anymore, it's subtraction, right? Now, the common mistake and your intuition or your instincts are gonna kick in and you're gonna say, all right, well, that just means I changed that into a plus, right? It's true, but you gotta do it for everything, right? Because it's subtracting all three of those terms. It's not just subtracting the first one. So what we need to do is we need to distribute that negative. We need to distribute the negative to all three parts. What's going to happen to those three terms when I distribute that negative? They're going to become the opposite. It's going to change the sign of all of them. Okay? So the first one's going to stay the same. N squared plus 5 is going to stay the same. But now I'm distributing, so I'm changing the sign of each one of those. So I change that to a plus 2n squared minus 2n plus 4. So I'm changing the sign of all of those in that second trinomial. And then once I change the sign, once I distribute that negative, now it's just like when we were adding. Now you're just combining like terms, putting it in standard form. The only thing different here is that distributing the negative to everything to start. Okay? Then I combine like terms. I would end up with 6n squared minus 2n plus 9. As long as you remember to distribute that negative, we should be okay. Any questions about it?
So playing games.
Okay, go ahead.
That's fun game.